Hey everyone! These are the 6th grade Math Statistics Guided Notes. Let's get started. Statistics is the study of data. Statistics uses statistical questions to gather data. A statistical question is a question that has variability in the data. What is the highest temperature for each day of May? This is a statistical question because the answers will vary. How many people went to the pool each day this week? This is a statistical question because the answers will vary. How old am I? This is not a statistical question because the answers will not vary. Write an example of a statistical question. So you need to think of a question that if you ask people, the answers will be different. Maybe some of them can be the same, but a lot of them can be different. They can get variable answers. So my statistical question is, how much do your friends' backpacks weigh? You're going to get different answers. Write an example of a question that is not a statistical question. So we're going to think of a non-example here. A question where it's only going to be one answer. So my question might be, what color is my backpack? If I ask people what color is my backpack, they're only going to give me one answer. Are these statistical questions? Write yes or no. How many teeth does my brother have? That is not a statistical question because the answers will not vary. How much time did the students in the class study for the test? That is a statistical question because the answers will vary or there'll be multiple different answers. Am I hungry? Not a statistical question because that's only one answer. Am I hungry? How many pets do your friends have? Yes, that will be a statistical question. The answers will vary. How many hours of sleep did your friends sleep last night? Again, yes, that will be a statistical question because the answers will vary. Statistic deals with lots of data. There are different ways to summarize the data. First, we would talk about the measures of central tendency. These measurements describe the average or the typical number in the data. The measures of central tendency are the mean, median, and mode. The mean is also known as the arithmetic average. To calculate the mean, sum the data points and divide by the quantity of data points. Let's determine the mean of the following data points. So here are my data points right there. The sum of the data points, so I'm going to add up 7 plus 12 plus 15 plus 20 and plus 21. If I add those all up, I get 75. The number of data points, so there are 1, 2, 3, 4, 5 data points. So I'm going to take 75 and divide it by 5, and that gives me 15. That means the mean or the arithmetic average is 15. It's like the typical number, the number kind of like in the middle of those data points. Calculate the mean of the data points 5, 10, 11, 15, 18, and 26. So first I'm going to sum 5 plus 10 plus 11 plus 15 plus 18 plus 26. When I sum those all up, I get 85. And there are 1, 2, 3, 4, 5, 6 data points. So I am going to divide that by 6. Now, if I take 85 and divide it by 6, I get 14.1666. So I am just going to round that to the nearest tenth and say that is about 14.2. That's about the number kind of in the middle of the data points. The median is the middle point of the data when the data is in numerical order. Let's find the median of the data points 10, 3, 2, 7, and 15. Write these data points in numerical order. So numerical order means like smallest to largest. So let's rewrite those numbers. So that would be 2, 3, 7, 10, and 15. Now the data point right in the middle is 7. So that is my median. Determine the median of the data point of these points right here. So I'm going to put them in order from smallest to largest first. That would be 1, 6, 13, 17, 18, 18, 20. It's always a good idea to count your data points 1, 2, 3, 4, 5, 6, 7 and count these ones 1, 2, 3, 4, 5, 6, 7 to make sure you have them all. Now I'm looking for the point right in the middle, and if you need to cross them off like 1, 20, 6, 18, 13, 18, Right here, my data point right in the middle is 17. What is difficult about finding the median of the following set of data points? Now notice that these are already in numerical order, so let's look for the number in the middle. 114, 310, 6 and 8. Both of those numbers are in the middle. There is no middle data point since there are an even number of data points. In the case of an even number of data points, the median is determined by calculating the mean of the middle 2 points. With the data set right here, 1, 3, 6, 8, 10, and 14, the middle 2 data points are, so we figured out that the middle 2 data points are going to be 6 and 8. So now I'm going to use my mean or my arithmetic average to figure out the median. So I'm going to go 6 plus 8, which is 14, and that's 2 data points. So then I'm going to divide it by 2, and that gives me 7, which makes sense since that is the number right between 6 and 8. So the median of this data is 7. Find the median of this data set right here. So let's first put them in numerical order. So I have 2, 5, 6, 7, 9, and 10. So we are going to find the middle number. So 2 and 10 cross out, 5 and 9. So my 2 middle data points are 6 and 7. That means I need to find the mean of those data points. So I'm going to go 6 plus 7, which is 13, and divide that by 2 because I'm finding the mean of 2 points, and that mean is 6.5. So the median of this data set is 6.5. The mode is the number most frequently repeated in a set of data. Let's look at the data right here. Now the number that is repeated the most would be the number 1. I have 3 1s, 2 9s, and then 1 4 and 1 10. So 1 is the mode. There can be more than one mode as in the data set right here because I have 1 7, 2 8s, 2 9s, and 1 10. So the number that is repeated the most will be 8 and 9 because they are both repeated twice. There can also be no mode if no number repeats, as in this data set right here, 5, 7, 9, 12, and 15. No number repeats even once, so there is no mode. Identify the mean, median, and mode of the data sets. So let's look at this set right here. We're going to find the mean, which means I need to sum all of those digits up. 3 plus 8 plus 9. I'm going to sum all of those up. If I sum all of those up, that gives me 70. And I have 1, 2, 3, 4, 5, 6, 7. I have 7 data points. So 70 divided by 7, that means my mean is 10. Now my median is my middle number when they are numerical order. This is already numerical order, so I don't need to rearrange the numbers. So let's look 318, 811, 911, right there. My median is 10. And my mode is the number that is repeated most often. So it looks like my mode is going to be 11 because that number is repeated twice. All right, let's look at my mean of the next data set. So I need to sum up all the data points. 20 plus 5 plus 8 plus 18 plus 3 plus 6. If I sum those all up, that gives me 60. And there are 1, 2, 3, 4, 5, 6 data points. So I'm going to divide by 6. And looks like my mean in this is also 10. My median is my middle number, but I need to have my data in numerical order, meaning smallest to largest. So let's rewrite my data set first. So 3, 5, 6, 8, 18, and 20. My middle point, 3 and 20, 5 and 18 will be 6 and 8, but I can't have 2 medians, so I'm going to find the average of those, the arithmetic average. So 6 plus 8 divided by 2 is 7. My median is 7. And my mode is the number that repeats most often, but there's not a number that even repeats once, so there is no mode. Okay, we're on the data set at the bottom. We are going to find the mean by summing all of these data points. 3 plus 6, we're going to sum them all up. If I sum those all up, I get 49. And let's count how many data points there are. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 data points, so I'm going to take 49 and divide that by 8. If I take 49 and divide it by 8, that is 6.125. I'm going to round to the nearest tenth and write 6.1. Now I need to find my median. First, the numbers need to be in numerical order, which they are. So let's find the middle number, 3, 7, 6, 7. Looks like my two numbers right there are 6 and 7. So I need to find the arithmetic mean of 6 and 7. So 6 plus 7 divided by 2, and that's going to be 6.5. And that makes sense because that is the number right in the middle of 6 and 7. So my median is 6.5. My mode is the number that repeats most often. So my 3 repeats twice, my 6 repeats twice, my 7 repeats 3 times, and then I have 110. So my mode will be 7 because that is the number that repeats 3 times. The measures of central tendency summarize the average of the data. Measures of variation summarize how much the data varies. Just as there are multiple measures of central tendency, there are multiple measures of variation. We will be discussing the range, interquartile range, and the mean absolute deviation. The range is the distance between the largest and the smallest data points. Let's use the data set right here. The largest data point would be 25. The smallest data point is 3. The range is calculated by finding the difference between these 2 points. So 25 minus 3, and that is 22. So the range is 22. Determine the range of this data set right here. So we need to take the largest number, which is 25, and subtract the smallest number, which is 1. So 25 minus 1 equals 24. The range is 24, and that's how much the data changes or varies. Create a data set of 5 points with a range of 10. So if my range of 10, that means my largest number minus my smallest number will be 10. So I'm going to use the numbers 20 and 10 and have 20 be my largest number and 10 be my smallest number, because 20 minus 10 will give me 10. So that will be a range of 10. Now I just need to choose 3 other numbers that are between 20 and 10. So there's my data set of 5 numbers with a range of 10. Now let's look at the interquartile range. The interquartile range is the range of the middle half of the data. To determine the middle half of the data, it is often helpful to visually divide up the data. The data needs to be in numerical order. So again, you need to have your data listed from smallest to largest. This data right here is already in numerical order. So we're going to divide it up into 4 sections. We can start by drawing a line through the median. So my median is going to be the number right in the middle, which is going to be 8. Now I'm going to draw a line through the median of each half. So I have these 3 numbers right here. So my median would be right here in the middle down here, and then right here in the middle up here. To find the interquartile range, I'm going to find the range of these numbers right here of 15 and 5. So I'm going to take 15 minus 5, and that gives me 10. The interquartile range of the data is 10. All right, let's do it again. So here's my data. It's already in numerical order. Let's find the median of the entire set of the data. I like crossing it out. That helps. Okay, so my median right here is 9. Now I need to find the median of the lower data set. So 3, 7. Oh, okay, my median's going to be right between 4 and 7. 4 plus 7 divided by 2 is going to be 5.5. So that's my median of my lower data set. Of my upper data set, it's going to be this number right here in the middle of 12 and 13. I can add 12 plus 13 divided by 2, but I also know the number 12.5 is the number right between 12 and 13. So let's answer these questions. It says, remember, if there are an even number of data points, you're going to find the mean of those 2 middle points. The median of the lower half of the data is 5.5. The median of the upper half of the data is 12.5. So to find the interquartile range, I'm going to find the difference between those 2 medians. 12.5 minus 5.5, and that is 7. Find the interquartile range of the following data points. Notice that is already in numerical order. If it wasn't, I would need to put it in numerical order. So we're going to find the median of the entire data set first, and that is going to be the number right between 12 and 18. Now, if I don't know the number right between 12 and 18, let's add it. 12 plus 18 divided by 2. 12 plus 18 is 30, so divided by 2 is 15. Now let's find the median of the lower data set. So we have 7 and 12 crossed out, 9 and 12. So that's going to be right here, 11. And of my upper data set, 18, 25, 20, 25. So my median will be 21. So the interquartile range, you will often see abbreviated as IQR. The interquartile range is 21 minus 11, which equals 10. Find the interquartile range of the following data points. Again, it is already in numerical order, so I do not need to rearrange the data. There are 8 data points, so my median is going to be right here in the middle. I need the number exactly between 20 and 22. That will be 21. If I don't know that, I can go 20 plus 22 divided by 2, and that will give me 21. Now I need the median of the lower half of the data, which should be right here, between 17 and 18, which will be 17.5. If I don't know that, again, I can find the mean. And the number right here between 23 and 27. Let's add those ones. 23 plus 27 divided by 2, and that is 25. So my median of my upper half of my data is 25. Now the interquartile range, IQR, is going to be 25 minus 17.5, and that equals 7.5. Let's analyze the mean absolute deviation, which is also a measure of variability. Mean absolute deviation is a measurement of how much the data points vary from the mean. So here are my data points right here that we're going to work with. First, we need to determine the mean of the data, and that gives us a hint in the name, the mean absolute deviation. So we are going to be working with the mean. So we're going to add all those data points up and divide by the number of data points. So 1 plus 5 plus 8 plus 8 plus 10 plus 15 plus 23. So if I add those all up, I get 70. And there are 7 data points, so I'm going to divide by 7. 70 divided by 7 is 10. So that is my mean. Now it says mean absolute deviation, meaning we are going to determine the distance that each point is away from the mean. Remember that all distances are positive. So how far is 1 away from 10? 1 away from 10 is 9. Now, if I don't know that, I can always go 10 minus 1. How far is 5 away from 10? That is 5. Again, I can go 10 minus 5. The distance between 8 and 10 is 2. The distance between 10 and 10 is 0. The distance between 10 and 15 is 5. We're keeping all of our distance positive. So remember that even though 8 is smaller than 10, it's still a positive 2. And 15 is bigger than 10, it's still going to be a positive 5. We're just counting the distance that number is away from our mean. So 23 is 13 away from 10. So now we have the distance from the mean of all the data points. Now to figure out the mean absolute deviation, we are going to calculate the mean of this data right there. So we are going to sum 9 plus 5 plus 2 plus 2 plus 0 plus 5 plus 13. If I sum those all together, that gives me 36, and then I need to divide by the number of data points, which is 7. If I take 36 and divide it by 7, I'm going to round that to the nearest tenth, and that gives me 5.1. The mean absolute deviation of this data is about 5.1. Let's do it again. Determine the mean absolute deviation of the following data set. So first, we need to calculate the mean. So let's sum up those 6 data points, 5 plus 12 plus 14 plus 22 plus 28. So if I sum up those data points, that gives me 102. And there are 6 data points. So I'm going to divide by 6, and that gives me 17. I need to determine the distance of each data point from the mean. So 5 and 17, that is a distance of 12. If I don't know that, I can go 17 minus 5. 12 and 17 is 5. 14 is 3 away from 17. 21 is 4 away from 17. 22 is 5 away from 17. And 28 is 11 away from 17. Notice that I have two 5s here, 12 and 22. They are both 5 away from 17 in opposite directions, but I'm still going to keep them positive. Now my last step is I need to find the mean of these numbers right here, the mean of the distances away from the mean. So I'm going to sum those up and divide by the number. So if I add those all up, that gives me 40, and there are 6 data points, so I'm going to divide by 6. 40 divided by 6, I'm going to round that to the nearest tenth, is about 6.7. So that means the mean absolute deviation is 6.7. Let's do some practice. It says determine the range, the interquartile range, and the mean absolute deviation of the data sets below. Notice that they are already written in numerical order, so I don't need to worry about that. So the range is the largest number minus the smallest number. So 35 minus 5, and that is 30, so that will be the range. The interquartile range, I need to divide this data up into 4 sections. So we're going to find the median first, which is right here, because there's 7 data points, so it's going to be right there. So the median of the lower half will be here, and the median of the higher half will be right there. So I'm going to find the range of 30 and 25. So 30 minus 25 is 5. That's kind of saying that the data in the middle only has a variation of 5. Now let's do the mean absolute deviation. So I need to first find the mean by summing up all those data points, which is 175 divided by 7, because there's 7 data points, and that gives me 25. So my mean is 25. So I need to determine the distance that each number is from 25. 5 and 25 has a distance of 20. 25 and 25 is a distance of 0. 25 and 26 is a distance of 1. 27 and 27, both of those, both have a distance of 2. 30 has a distance of 5, and 35 has a distance of 10. Now I need to find the mean of this data. So if I sum all that data up and divide by 7, so I get 40 divided by 7, which means the mean absolute deviation, often abbreviated MAD, is going to be about 5.7. All right, now we are going to figure out the range, interquartile range, and mean absolute deviation of this data set right here. Again, it's already in numerical order, so I don't need to rearrange that. The range is the maximum minus the minimum, or the largest minus the smallest. So 26 minus 11 is 15. My interquartile range, I need to break up my data by the medians. So we have my median here in the middle, which is going to be 21. And then the median of the lower half of the data, there's 4 data points down here, so the median is going to be right there, and that will be 16. I can find the mean of 15 and 17 if I need to. And the median right here is going to be 25, because the number between 25 and 25 is also 25. So the interquartile range would be 25 minus 16, which is 9. So my mean is the sum of all of these data points divided by the number of data points. If I sum up all of those data points, I get 180, and there's 9 data points, so I'm going to divide by 9, and 180 divided by 9 will give me 20. So that is the mean. Now I need to figure out the distances away from the mean. So 11 is 9 away from the mean, 15 is 5, 17 is 3, 18 is 2, 21 is 1, 22 is 2, 25 is 5, and 26 is 6. Now I need to find the mean of this data right there. If I sum up these distances right there, I get 38, and then I'm going to divide that by 9, and that is approximately 4.2. Statistics is often displayed visually to summarize the data. One data display is called a box and whisker plot. This display shows the median and variability. A box and whisker plot is divided into 4 sections called quartiles. The sections are numbered in order. Label the quartiles below. So this is a box and whisker plot because it has these two boxes in the middle, then it has whiskers on each side. So the quartiles will be in order. So this will be the first quartile, this little whisker. Then the first box is the second quartile. The second box is the third quartile. And then you have your whisker at the end, which is the fourth quartile. The boxes here in the middle represent the interquartile range, which we talked about on the previous pages. The longer these quartiles, the more spread out the data is. If the quartiles are shorter, then the data is spread out less. So if I'm looking up at this, I can see that this right here, this quartile is longer than this quartile. So this data in this quartile is spread out more than the data in this quartile right here. To create a box and whisker plot, you need the following 5 data points. And these are all data points that we already talked about finding. So the minimum, which is the smallest number, the maximum, which is the largest number, the median, which is that number in the middle, and then the median of the lower half of the data, and the median of the upper half of the data. So those are those 5 data points. Let's find the 5 data points for the following set of data. Notice that it is already in numerical order. If the data is not in numerical order, you are going to need to place it in numerical order. So the minimum or the smallest number will be 3. The maximum or the largest number is 21. And then I need the middle set of the data. And there are 1, 2, 3, 4, 5, 6, 7. There's 9 data points. So my middle data is going to be right there. That's 4 on each side. So my median is 12. Now I need to find the median of the lower half of the data. So the median right there, and we talked about this previously, it's going to be the number right between 5 and 7. I know that number is 6, but if you don't know that, you can go 5 plus 7 and divide that by 2, and that will give you 6. Now I need the median of the upper half of the data, which is going to be right here between 14 and 18. If I don't know that, I can go 14 plus 18 divided by 2, and that will give me 16. So here are my 5 data points, 3, 21, 12, 6, and 16. Now I'm going to create a number line and plot those points on the number line. So I have 3, 21, 12, 6, and 16. Now we will create boxes by connecting the middle 3 data points. So I'm going to make boxes out of this here. So we have this, and I'm just going to go like this and make 2 boxes with these data points. Connect the first and second data points as well. So then I'm going to connect these right here and then the last 2 data points. And I have created my boxes and my whiskers. Now let's answer these questions. Which quartile is the data spread out the most? So I'm looking at the quartile that is the longest out of these. Looks like this one right here. So this is my second quartile. That is the longest quartile, so that means my data is spread out the most. Which one is my data spread out the least? So I'm looking for the shortest quartile. That looks like my first quartile. That one's the shortest. Let's do it again. Create a box and whisker plot with the following data set. Again, it's already in numerical order. If it's not, I would need to put it in numerical order. Minimum is 7. Maximum is 31. Median is going to be this number right here, 18. Median of the lower half of the data is 9. Median of the upper half of the data is 29. So there are my 5 data points that I'm going to plot on a number line. So I have 7, 31, 18, 9, and 29. Now I'm going to create my boxes and whiskers. So my first one right here will be a whisker right there. And then I'll have a whisker here on the end. That's going to be a short whisker. And then I'm going to create my boxes here in the middle. So it says, which quartile is the data spread out the most? It looks like this one right here is my longest quartile. So that is my third quartile. And which one is the data spread out the least? It's going to be this one right there, my fourth quartile. Another visual display of data is with a dot plot. Dot plots show the frequency. They work best when you have small amounts of data. So if you create a small table first, that will help you organize the data. Let's use the following data, which shows how many books were read by 15 students over the summer. So here's my data. 15 points is not too many. If I had like hundreds and hundreds, I would not probably want to do this by hand. Finish the frequency table below by determining how many times each number appears. So frequency is how often something happens. So I see the number 0 one time in the data. The number 1 is up there 1, 2, 3 times. So I'm just going to go through and figure out how many times each number appears in my data. So I went through and calculated the frequencies for each number. Now again, I'm going to need to create a number line. The number line is going to need to include the numbers of my data. My data goes from 0 to 8, so we will do that number line. I did it 0 to 9, which is fine. So now we're going to do dot plots to represent the data here. 0 is 1 time, so it's 1 dot. 1 will be 3 times, so we're going to do 3 dots. And you want to do this nice so you can actually get some information from it. Number of books, 2 will be 3 times, so go ahead and finish filling out your dots. There is my dot plot. Notice that I have no 7 in my data, so this will just be left blank. But notice how I did my best to kind of line up my dots horizontally. That is important. How many students read more than 4 books? So more than 4 would be this right here. So that would be 4. What is the number of books most frequently read? That's going to be my highest tower right there, which is 3. How many students read less than 3 books? So that's going to be right here, and that would be 7. Then it says to mark the gap on the number line. So we're just going to go right here and write gap. Create a frequency table and a dot plot for the following data. So we need to write all my data points here that are in my numbers. So this is kind of a lot, but I'm just going to first look for my minimum, which is 6, and my maximum is 15. So I know it's going to go from 6 to 15. There's our 7, there's 8s, there's 9s, there's 10s, there are 11s. I don't see any 12s or 13s or 14s. So I don't need to worry about those numbers. Frequency is how many times the numbers appear in the data. So go through and fill out your frequencies of each number. So for example, 6 appears twice. So you will write a 2 under the 6. All right, so this is my frequency table from 6 to 15 and how many times each number appears. Now we're going to create my dot plot. So my number line is going to need to go from at least 6 to 15. And remember, it's a number line. So even though there's numbers right here that are not recorded in my data, I still need to show it on my number line. So there is my number line. Now I'm going to put dots on each of the numbers for their frequency. So for 6, there will be 2 dots. Now go through and complete your dot plot. There is my dot plot. Remember, this is a number line and the intervals must be equal. We talked about that previously. You can't go from like 11 to 15 without these numbers right here, even though they're not part of the data. Which age is most common at this summer camp? So I'm going to look for my highest tower, and that's going to be 7. How many children are less than 8 years old? Right here. So those dots, there's 6. How many children are more than 9 is going to be these dots right here. So adding those up is 7. Mark the gap in ages on the number line. So then I'm just going to mark this gap right here. Another visual display that also shows frequency is called a histogram. These displays look similar to a bar graph, but show frequencies of an interval of data. These are especially helpful if you have a lot of data. So if you have a lot of data, histograms would be better. If you don't have as much, you would probably want to use dot plots. So this is a histogram of scores on science exam. So it looks kind of like a bar graph, but it's showing intervals of data. So for example, 2 people had between a score of 50 and 59. 3 people had a score of between 60 and 69. The histogram above is of scores on a science exam. How many students scored 70 to 79? So 70 to 79 would be 6 people. How many students scored 80 or above? So 80 or above would be 10 plus 4 would be 14. The y-axis shows, so my y-axis right here is the frequency of the scores. And the x-axis shows the scores. How long are the intervals on the x-axis? So I'm looking at these right here. Those intervals are 10 numbers. So 50 to 59 is 10 different scores. Now you don't always do the same intervals. It just depends on the data. Intervals on a histogram must be the same length. Intervals cannot skip numbers. So for example, up here, each of these include 10 scores, and that has to be consistent throughout the histogram. And notice that no numbers are skipped. It goes straight from 59 to 60, 69 to 70, plus all those numbers in between. Look at the 3 sets of intervals below. Circle which interval set would work for a histogram. So looking at this right here, would this work for a histogram? I have the numbers 1 through 8 and then 9 through 20. Well, that's not going to work. That includes 1 through 8 is 8 numbers. 9 through 20 is more than 8. So I can tell right off the bat that these intervals will not work for a histogram. Well, let's look right here. These are 1, 2, 3, 4, 7, 8, 9, 10. These are all including 4 data points. But if you notice, it's skipping data points right here between the sets. So this would not work as intervals for a histogram as well. These all include 5 data points, so that works. And I'm not skipping any data between the intervals. So my last one will be the intervals that would work best for a histogram. We'll just circle that. Let's make a histogram for the following data. Using a frequency table will help you organize the data. Complete the frequency table below. So here is my data. It's the temperatures in Springville, and these intervals are already included for us. If not, I can make some my own. I need to count the numbers that are between 50 and 59. So just looking all the numbers that start with 5, and that would be 2. The numbers between 60 and 69 is 2. The numbers between 70 and 79 is 4. The numbers between 80 and 89, and that's 10. And the numbers between 90 and 99 is 2. Write the intervals on the horizontal axis below. Determine the scale for the y-axis by looking at the frequencies. Title your graph and axis. Okay, let's first title my graph. And this is temperatures in Springville. Now I need to title my axes. On my y-axis will be frequency, and then my x-axis will be the degrees in Fahrenheit. Okay, now I need to look at my frequencies. My frequencies go from 2 to 10, so I need to include at least 2 and 10. Remember, these are like number lines, so I can't skip numbers. So how about I go by 2s? From 0 to 10. And then I'm going to write my intervals down here on the bottom. So 50 to 59, 60 to 69, etc. Okay, now let's make my bars. So 50 to 59 is 2. 60 to 69 is also 2. 70 to 79 is 4. 80 to 89 is 10. And 90 to 99 is 2. That is a histogram of my data. Practice. Make a histogram for the following data. Use the table below to help organize the data. It already has my intervals set up for me. There are 10 data points in each of these intervals, and I'm not skipping any numbers. I'm going to count the numbers between 5 and 14, also including 14, and that is one right there, 5 and 11. So that's 2 data points. I'm going to go through and finish filling out these frequency tables. Here is my frequency table for my data. Now I need to make a title for the graph and label the axes and complete my histogram. The title of my graph is going to be Ages at a Concert. My y-axis will always be frequency, and my x-axis will be the data. So this will be ages. My frequency is going from 2 to 10. I'm going to do the same thing as before. I'm going to go by 2s on my y-axis. And now I need to make my intervals here at the bottoms. Now we will make my bars. So 5 to 14 is 2 people. Continue making your histogram. Your histogram should look something like this. How many people are between 35 to 44 at the concert? There are 6 people. And how many people are younger than 25 at the concert? That's going to be this group right here, and that's 12 people. Okay, everybody, that's it for today. Thank you.